And so we have a cycle that would look something like this. So days would be like from the day you seeded until the day you harvested, or the day that if it's a perennial, the day that it starts leaf development till the day it loses its leaves would be their crop year for this particular crop. And then this would be rate of water used. And this would be inches per day would be a typical rate here, and this would be days on this cycle. Most plants, or most crops are going to look like this. They're going to start, the actual consumptive use is going to be, there's going to be some transpiration, or excuse me, some evaporation all the time off the soil surface, even back in March or April when this plant gets started. So we're going to be starting up here somewhere. There's going to be some rate of water used. So this is going to be the CU in inches per day. There's going to be some evaporation even though there's no transpiration. And then what it's going to do, out here somewhere, we'll call this maturity. This plant is going to cyclically use more and more water till it hits that peak, and then it will just drop off on its downside. So that would give you a kind of a vision of what's going to happen. So out here at maturity sometime in late July, early August, most of these crops peak in this part of the world. And at that point we hit maximum use. That'd be a different story if this were wheat. If this were spring wheat, this might be the middle of February, and this would be out here where you harvest could be July 15th. So it would totally depend on the type of crop. This would be, if this were corn, this would be sometime in April, and this would be sometime in October out here when you harvest that field corn. If it's sweet corn, this could be sometime in maybe June, and this could be sometime in late August. So crop dependent on how this is going to be, but most crops are going to have some kind of a look like this. The only one that really doesn't is turf. It doesn't have a big change except for the temperature. So depending on the temperature swing through the hottest part of the summer, it's probably going to reach up and then it'll taper back off again. But it's pretty constant user because, see, it's a full growth plant. And it's just going to rely on the seasons as far as the amount of evaporation that's occurring. It's going to be heat dependent there. And then its transpiration, it'll grow faster. In fact, when does it grow its fastest? In this area and in this area. It doesn't. Most cool season grasses aren't going to have a lot of transpiration during the hot part of the summer. They start to shut down, but the evaporation goes up. So they're more of a flatliner. We use more water that time of year just to keep them from going dormant. Cool season grass, right in here, boy, it'd like to just shut down altogether. It'd rather just kind of go into hibernation there for a little while. But we don't want it to. We want to keep it green, and so we keep tricking it into staying green by irrigating it. Climate is obviously going to have an effect. And the effects on climate are going to be the amount of solar radiation we get. Heat units are a great way to evaluate how much consumptive use we're going to have. So we can monitor heat units, we can really get that value. Heat units are very dependent on solar radiation. Other parts would be air temperature. So we got solar radiation, air temperature. The hotter it is, the more consumptive use. The cooler it is, the less. Obvious. Humidity is another climatic factor. And in humidity, the greater the humidity, the less the consumptive use. See, the air is already being saturated with water. It doesn't need more. So the plants don't need to, or the soil is not going to evaporate into an already moisture-laden air mass. There's no need for the exchange. It's already got all the air at once. Plants are going to do some transpiration, that's true, but it'll slow down when you have high humidity. Rainfall. Rainfall is going to have an effect. There's nothing like Mother Nature to change atmospheric conditions. Builds humidity in the air. Obviously, it supplants what we have to do as far as irrigation is concerned. Plus, we get almost perfect uniformity when it rains, as close as you can get. And so lots of times rainfall can be an advantage to us by just changing the climate conditions. And then last but not least would be wind. And wind is going to have a drying effect. The greater the wind velocity, the more drying occurs. You're creating an energy gradient and it's going to draw water. Because you're moving air across the surface that is going to be picking up moisture. Reduce the wind, that's going to reduce evaporation. In a desert climate, that's really true, because what happens is you're bringing in dry air all the time out across your irrigated acres. Now, if you have on the coast a wind that's totally saturated with moisture already, then that becomes a moot point. Doesn't it work that way? But if we're in an arid climate where that wind is a dry wind, it's bringing in drier air all the time, it's going to create even more of a evapotranspirative effect on the crop around you. So we really hate to see those hot, dry winds in this part of the country in the summer, because it just sucks the life right out of everything. And we call them in this country the north winds that blow, and boy, the humidity drops down into single digits, and you're moving all that hot, dry air across anything that's green. It's just trying to pull moisture out of it as it blows across it. And it's constant change. You know, you're getting another cubic foot of air every few seconds that it's wanting to load more water into. So if it were stagnant, if it's just hot and the air is still, it will start to load up some humidity, and the humidity will build right in the neighborhood. With the wind blowing, it doesn't let the humidity build, it just moves it right on by and brings in more dry air. So you're kind of fighting a double battle there, both heat and low humidity at that point. Now, how do they go about determining the consumptive use? You know, how do you measure it? Well, it's not easy. And really the only true way to really measure it is to actually weigh a soil and crop that's growing in that soil and weigh it over time. And what they do is they actually, in some of the universities around the nation, they have these big earthen miniature fields, effectively. They're just big round growing areas, big tubs. They're buried in the ground on a set of scales. They're called lysimeters. And the way to get a true reading is to use a lysimeter. See if I can spell that word.